Alright, so we're here at the blueberry
Give me
bushes,
the phone.
and you wanted to know what blueberries and measuring cups have to do with black holes and density, right?
They don't have anything to do with them.
Well, alright, here, you hold this. Alright, point it down here. Now, hey.
You mean like that down there?
Come on, please.
Okay.
Alright, so, oh, stop. Alright, now, we've got a certain amount of blueberries here, right? It's going to stay the same amount. Oh, okay, put those blueberries in, or eat them. Okay, there you go.
I'll say 102.
Sure, we have a certain number of blueberries. Now, do they have much room to move around here in this, this thing? Well, how many cups can it hold?
4 cups.
Right.
A little bit more than that.
And there is plenty of room for those things to move, right?
Right.
So this is not a very dense situation of blueberries, right? Especially if they were a gas, they would just spread out all through here, and they'd be spaced out a lot. Right?
Right.
Okay, so here they would be spread out and yummy. Well, now, what if we go from a 4-cup container to just a 1-cup container?
Uh-oh.
Do you think that's going to be a little bit more dense?
Mm-hmm.
Well, let's find out.
Stupid measuring cups.
All right, hold on. I think we're going to be able to fit everything in here. All right, 1 cup.
That's so dense.
That's quite a bit more dense, right?
Right.
What if we go down to a 1/2 of a cup?
It'll overflow.
Here, take the camera. Stay down here. I'm going to do it right. All right. Now then. We got this.
I don't think it's gonna fit.
I'm gonna pour it in.
It's not gonna fit.
Right,
it's overflowing.
What if we started squishing it down and making it more compact? Do you think it could? Yeah, ew. But it'd work, right?
True.
We could squash these down and it would fit
Then do
into
it.
the 1/2 a cup. I don't want to do it. We're gonna eat these blueberries.
Yay!
Okay, so if we squash it down, it would become more dense and it would be able to fit in this smaller area, right?
But it would be very, very dense.
It would be very dense. Now, what if we took a 1/4 cup
on.
and we put them all in?
And we smashed them.
Smashed them even more and got them more dense. We'd get them to fit, but they'd have to be even more dense, right? Okay, so here's the thing. Let's say that we're measuring density as a number. And let's say that right now, with the blueberries in this 4-cup measuring cup, the density is 1, okay?
Okay.
And then, let's say that we go from 4 cups to 1 cup. Does the density go up?
Yeah.
By how much? How much more dense is it?
3.
From 4 cups to 1 cup,
3 cups.
it's 4 times more dense.
3.
No, it's because 4 cups to 1 cup, we're doing multiplication, not subtraction.
Oh.
So it's because, yeah. So it's 4
Math
times
is
as dense,
weird.
okay?
Math
Now,
is
Aurora,
weird.
what if we go from 1 cup to 1/2 of a cup?
Oh no.
How, so let's say,
That would be...
let's say this was a
8.
density of 1. Right. This is a density of 4.
That would be 8,
1/2 a cup.
and that would be 16.
Right. Okay. Now you've got it. So as we get smaller and smaller, it keeps going, the density number keeps going up as the fraction gets smaller and smaller, right?
Right.
Now what if, instead
Dad,
of...
When you're done with this, you should really post this on your blog.
Okay, so what if we go from 1, which is a density of 4, a 1/2, which is a density of 8, a 1/4, which is a density of 16.
That's easy.
Now, what if we go to a density of 1/8?
That'd be 32.
Right. That would be a density of 32. What if we keep getting smaller and smaller and smaller until the container size is 0?
That'd be almost infinity.
Yeah! You would have a density of almost infinity, right?
And I
Now
think it would be infinity.
you start to get the concept of black holes. Is you've got all this matter and the density, the area is almost 0. Did it stop recording?
No.
Okay.
I just accidentally moved my pinky.
Got it.
In the lens.
The area, yeah, you're kind of moving the camera all over the place. All right, so with black holes, you've got an area of almost 0,
Right.
and so the density becomes
Almost infinity.
almost infinity. Okay.
It is infinity.
Well, almost. And we also see why
Impossible numbers.
when you have a calculator and you try to divide by 0,
Just goes error.
it gets an error because you'd think, oh, divided by 0, that's 0, but it's not. A number divided by
His
0,
wife said that.
Stop. Okay, a number divided by 0 is that density number. It keeps getting, as it gets closer and closer to 0, the density gets closer and closer. Yeah, you're kind of going
I don't care.
crazy with the camera.
Yummy blueberries.
The density gets closer and closer to infinity. So, same thing with dividing by 0, and same thing why black holes would